welcome to another video in the Mastering Kubernetes series. So in the previous videos, we talked about various installation methods. Now I'm going to talk about the Kubernetes architecture. Okay, so without any further delay, let's get started. So if you see on my screen, if you talk about the Kubernetes architecture, there are two major components that we have. One which is control plane, two the data plane. So control plane is considered as the core of the Kubernetes, where the entire functionality of the Kubernetes is handled by the control plane, and data plane or is something where you run your workloads, probably your websites, your DBs, all your pods, deployments, all of that, your applications primarily. Your applications all will be running on the data plane. Okay, so control plane basically consists of few major components. So these components can be installed together on a one single instance, node, physical server. All of these are the same, guys. Okay, do not get confused. When I say node, when I say server, when I say physical server, when I say VM, all of this represents the same thing. Okay, so control plane has various components. Okay, if you see here, we have API server, scheduler, controller, etcd, and there are additional add-ons depending on the kind of functionality that you want within a given cluster. We will install the add-ons. Okay, so these API server, scheduler, controller, etcd can be installed on one server, or you can segregate them. You can have API server running in a one dedicated server, scheduler running in a dedicated server, controller, etcd. All these major components can run on altogether different servers. Okay, depending on the kind of applications or infrastructure that you want to build. If you want to build a highly available infrastructure, you will go with having them configured across various servers, and you will build a high availability between them. Okay, so while you are practicing, I would not suggest having them spread across multiple nodes. Okay, you can have all of these components running on a one control plane, and you can have multiple data planes where you will segregate your workloads. That's one best method that you can do while you're practicing. In the production environments, if you are building your own Kubernetes cluster from the scratch, there are different approaches basically. So in that case, we always maintain the odd number of servers. It could be 3, 5, 7, but most of the cases people go with 3 servers, and within these 3 servers they will segregate your API servers, etcds, and the other components. Okay, so let's not get into that and give you a confusion there. So whatever the installation methods that we are going to see, I will be showing you configuring all of that on a one single node. Okay, so API server, scheduler, controller, etcd add-ons. Okay, this is fine. I think you understood what the components that we have, but what does these components basically do, right? What is the purpose of each of these components? What are they responsible for? So if you look at the API server is an interface that you talk to in a given Kubernetes cluster. Let's say you are onboarded to a new project and your manager asked you to go ahead and verify the cluster status. How are you going to do that? So that's where you will start communicating to the API server. So from your local laptop, you will have an API server, and that's where you will be connected to. That's where you would connect to, and then you will start talking to. So you have a cluster and you have your own laptop where from where you're trying to connect to. So your interface So the component that you will try to reach is the API server. So you won't be able to talk to scheduler, controller, etcd, add-ons, etc. directly, but the only mechanism for you to interact with your cloud, with your Kubernetes is API server. Okay. Scheduler. So let's take a simple analogy here. Imagine you are working as part of a team. Okay, you are a team leader. Now, if you want to delegate some work to your team, you know who has a space, like who is occupied and who is free from the project. So when you're delegating work, you need to understand what is the bandwidth they have, whether they have the proper resources for you to deliver this specific project. All of these things are handled by the manager, right? So your scheduler acts as a manager now. So it's like the project manager receives the request, which is an API server. So this API server will delegate it to scheduler. Now it's the scheduler responsibility to distribute the load across your nodes. Now I want to build 5 pods. So in order to build these 5 pods, I might need some, let's say 5 GB of memory and maybe 20 GB of space or maybe 10 CPUs. So this information, the availability of the resources information is managed by scheduler. So the API server will tell the scheduler that, hey scheduler, I have a requirement to provision 5 pods. Can you tell me what are the nodes where I need to place this, or you take care of this thing? So the API server will pass the information to the scheduler, and scheduler will place the pods on the right node depending on the availability of the resources. There are various constraints that scheduler will take consideration into, out of which resources, labels, annotations, right, selectors, all of these are there, which we will discuss step by step in the future videos. But for now, understand that scheduler is one such component where it is responsible of placing your pods on the right nodes depending on the availability of the resources. Okay, yeah. Now the controller. So the controller's responsibility is that, so now API server received a request of provisioning 5 pods, and that request is handed to scheduler. Now scheduler makes sure that these 5 pods that we are going to provision are getting the adequate resources, and it plays them. These pods are running up and running fine. Now imagine there is a failure on the node on which one of the pod is running. Okay, the node went down for some reasons. So in that case, what happens? Okay, so in that case, the controller takes the responsibility of making sure these 5 pods are going to run no matter what the state of your cluster is. So this controller will see that, okay, hey, one of the pod is down, but API server told that we should have 5 pods up and running, but there are only 4 running, and because one of the pod went down. Now the controller will take that responsibility and will try to re-provision one more pod for you. So at any given point of time, the controllers will make sure that desired capacity of the pods are running. So they handle the failovers, they handle the reprovisioning of the nodes, reprovisioning of the pods. So there are different controllers also available, okay, which we will talk in the coming sessions again. But for now, understand the main responsibility of controllers is to take the responsibility of managing the desired state at any given point of time. Now etcd, here comes the elephant in the house, right, the major component. So let's say you are building a huge cluster and so now the cluster has many deployments, many pods all together, and all of a sudden the cluster went down. Okay, now it's your responsibility to bring back the cluster, but how do you know what was the previous state of the cluster? Like, it's not about just bringing the cluster up, right? It's about bringing all the applications running inside it to the state where they were running previously. So how do we do that? So this entire information of the number of pods, deployment, services, the firewall rules, everything related to cluster is stored in a database, and that database is called etcd. It is very crucial that you take the etcd backups in case if you are managing your cluster by yourself. But if it is in a cloud provider, primarily the AWS and all, you don't have to worry. So they take care of the etcd backup and everything. Okay, so yeah. And add-ons, it is a key value pair database, by the way, and the add-ons are basically something which enhances your the cluster functionality. Let's say the cluster doesn't have a GUI. You want to build a web interface to see or monitor your Kubernetes environment. Then you can have a dashboard add-ons. Okay, you want to work on some networking components, so you wanted to have that functionality, then you can go with some networking add-ons. So like this, the enhancement of the cluster is taken care by these specific add-ons. Okay, so this is the whole architecture of the Kubernetes basically. So now I will show you a picture which represents whatever I'm talking about. So here I am showing you in the form of a org chart because it simplifies the learning process. That's what I believe, and that's what I learn things. So that's what I wanted to give it to you as well. But in the next video, I will show you how this entire structure is going to work with a diagram illustration. See you in the next video.